Am I audible, guys?
Yes, sir.
All right. Okay. So the second project is on a different topic than the first one. Let me share my screen. Okay. Are you able to see my screen?
Yes,
Yes,
sir.
sir.
All right. So the second project discusses about web application development for simulation and visualization of motion in waves. And this was a project which started in just this summer. So the summer of 2020, right after your classes were over and the pandemic started and all of you were sent home, I sent out an email to the NA17 batch asking them for if they would be interested in pursuing a internship with me in order to develop this program. And the three of them have joined in and they have created a web application out of it, which is the link which I sent you to where we are simulating the motion of waves, motion in waves of a floating structure, and then are also able to visualize it. So let's talk a little bit more about it, and probably I will shift over to the website where the application is hosted in order to give some more details. Let me talk about the prime motivation behind this. So the main motivation is that the undergraduate students, when we teach them, we talk about different things in the class and we discuss about different things like dynamic response, how the heave response, pitch response, roll response. But these things to me don't make much sense until they are able to visualize them. And a student should be able to visualize the dynamics in the ocean, and only then can they really appreciate, hey, this is indeed a big deal. So for example, when I was working on parametric roll, and I'll talk more about it towards the end of the presentation, and I'll show you a couple of videos which talk about the visualization which I built, which was much more rudimentary than what your friends have been able to achieve in the last 3 months. Okay. So the idea is that use of this program will allow us to bring it into the classroom, and whatever we are discussing in the classroom, we should be able to show it as a simulation exercise, which one can visualize and understand the subject a little better. The other aspect is we want to reduce the dependence on commercial software. So commercial software, anyway, one has to learn if you want to stick to this field and you want to continue working in the area of naval architecture. There are certain commercial software which you do have to learn. But as an academic institution, it makes a lot of sense for us to have a code of our own, which we can tweak, which we can modify. So for example, when we are teaching something, a question might come up, what happens if this does not happen? If we don't consider added mass, for example, how does the dynamics differ? These are some things which you may not be able to do in a commercial program, but these are some things which we can do in a code like this because the source code is completely developed by our reps. Okay, so that's the primary idea behind it, and to enable teaching better and to reduce the dependence on commercial software in the teaching application side of it. So this code is nicknamed SIMDYN, and it's short for simulation of dynamics. I asked your three friends to come up with a better name, but they wanted to stick with this name, which is why we have went with it. So that goes it. Okay. So what this code can do is it can simulate the linear and the nonlinear motions of ships and platforms in a real ocean. So you set what the wave environment looks like, and once the wave environment has been set, you can simulate the process and see how the ship actually responds to those waves, and you can actually see the visualization of it. And that I think is the coolest feature of this simulation of dynamics. And the idea is that it is built primarily by undergraduate students. I am not involving any graduate students I am primarily relying only on undergraduate students to build this project. The reason behind it is I want it to be built in such a simple manner such that other undergraduate students can easily use it, try it out, test it, see how it works, and then continue building upon it if it's that interest. So currently it is hosted on a AWS server. So let me go to this link and show the application. Okay, so this program, I can quickly go about here and show. Yeah, so about the team, you'll see that there are 3 students, Arundhati Chandrasekharan, Ashwin Vijay, and Manoranjan. Those 3 people have built this portion, and they have also described the part of the development which they were involved with. And I really like this part because they have given a very open account of what their eyes, how they viewed the internship progress has happened. And I think that is useful from a point of view of if anybody wants to continue working on this project or is interested in this project, I encourage you to take a look at their experience so as to understand a little bit of how it suits you in going forward with it. Okay? Now, in the simulation tab, you can set up the number of vessels. So let us say I want to set up 1 vessel, and let us say I want to choose a GDF file. So GDF means the geometry file. So that is what we are choosing here. And a diffraction file, let us say we are choosing a single body case and added mass, which we have obtained from it. So this added mass file and diffraction file are obtained from a standard frequency domain program. So you might have heard of things like VAMIT. Have you heard of VAMIT? How many people here have heard of VAMIT? Nobody? Okay, it stands for Wave Analysis MIT. It was built by MIT, and that has kind of become the industry norm for the frequency domain program for analyzing the motions of the vessel. So we take the input from in that standard manner from a frequency domain program, and we provide an input file of our own, which is a text-based file, and we simply hit simulate, off it goes, and it starts to simulate. So let it simulate. Once the simulation is done, I'll come back and try to show how it looks like. So in the meantime, let us come back to our presentation and proceed further. So these are the current developers who have brought this in, and I think Ashwin has been particularly involved in the visualization aspect of it in order to bring through JavaScript, bring it live as to how actually the vessel responds in the motion. And Manoranjan and Arundhati have also been involved in the web application side of it in order to create the user interface and other things. And all 3 of them have been involved primarily in different aspects of building the program in the numerical scheme behind the program with some assistance from me here and there. Okay? So it's primarily been written by undergraduate students. So as a part of this project, what we are looking for, so if you want to come join this project, what we are extensively looking for is extensive testing. So we want this application which we have hosted, it is still been only tested for a couple of dynamical problems, but it would help if students can help test the application for different types of dynamical problems, for offshore structures, for ships, and see what sort of funny things can it happen. Does it behave okay, or sometimes does it behave crazily? These are the things which we definitely want to find out, and then come back to the drawing board and discuss. Why does it do this? Is that a real phenomenon, or is it something not real? If it is not real, why is it occurring? So things like this is what we want to question, and we want to continue the development of the code based on our asking these questions. Okay? Currently, the code can simulate multiple bodies, but in calm waters, not calm waters, when the ships don't have any forward speed effects in them. So, for example, an offshore structure or a vessel which is not moving forward with certain speed. So such kind of structures can currently be analyzed. You can put multiple of them and you can analyze them. So therefore, we require some development of further modules, and I'll talk a little bit more on what are the different modules that we need to develop in this code to succeed it further. The other aspect is to improve the computation speed. We are always interested in seeing how the computation speed can be increased and what are the different methodologies we can come up with to fasten the code from a standpoint of better algorithms. How can we implement them in order to do the same things? Like, one of the challenges which we do face currently is computation of wave elevation over a large grid for the visualization purpose takes a considerable amount of time, and that is something which should be sped up, I believe, and I think that is one good area where we definitely will be interested. So let's discuss more about what are the different challenges which you will be addressing if you are interested to work with us on this. So one project will be depending on developing a mooring module. So currently the vessels do not have a mooring module associated with this time domain program, but you all know that a typical offshore structure which is floating is never left as is, but it is actually moved down to the ground using mooring lines. And the challenge here will be to program a finite element method based mooring module, and it will rely primarily on concepts not requiring you to go beyond the course. Whatever we will be teaching you in, or what will we will be teaching you, or I have already taught you in OE 3015, the ship structural analysis. Those are the concepts which we will be primarily be using in order to develop a mooring module. And once we have the mooring module, the idea is that you can now simulate offshore structures, and you can even perform experiments in our wave basin in order to test out whether the reality and the simulation program are working correctly or not. So I think that's a great way to see both the aspects of it. You get to see how to numerically build a code and do it, and then come back and perform experiments and still be able to verify that the two agree very well. The other aspect which I will be interested in is what is known as maneuvering module. So as I said, currently we are not including forward speed effect of the vehicle. So that is a problem which we do need to include and which will allow us to simulate different types of maneuvers of vessels. And so for that, somebody has to program the maneuvering forces, the rudder forces, and these ideas will be discussed in the course which we will be taking in the next semester. Now, some of you have already taken this course with me who are in your NA17 batch, and we are already aware about these ideas. So those programming of those maneuvering forces and rudders will allow us to add extra dimension to our program, which is currently not there. One of the challenges which a lot of industry is currently working on is what is known as maneuvering in waves. It's still an unsolved problem in the industry, where the idea is that because they want to reduce emissions of the vessels, the Kyoto Protocol, which was deciding on how the emissions should be, is coming close to an end in 2018. And since then, they have not revised it. So there is some changes which are going on. And based on that, there is this big drive towards making ships a little bit more green, or in the sense energy efficient, and reduce the emissions which the ships provide. So one way to do it is to reduce the power of the engine, and if you reduce the engine power, automatically the emissions obviously will reduce. But there are other challenges which come around because of the reduction in power. And when you reduce the power, one of the big challenges is you can maneuver fine in calm waters, but when you have waves along with where you want to maneuver around them, there are certain things which you may not be able to do. So the waves might push you in certain directions, and if you don't have sufficient power, you may not be able to overtake those forces and go in the direction in which you want to proceed. So problems in that area are called maneuvering in waves, and it's a very challenging area because you have to design a framework where it works we are able to deal with sea-keeping modes and maneuvering modes together. And the challenge is the sea-keeping modes are generally faster. So sea-keeping generally refers to roll, heave, and pitch. And they are in response to the waves. So those motions are on the order of seconds. But then your maneuvering comes in surge, sway, and yaw, and it's on the order of minutes. So how do you do this multi-scale? One time scale is in seconds, the other time scale is in minutes. How do you combinely simulate these exercises together to perform these maneuvering in wave calculation? Is one different module which we would be interested in adding to the simulation of dynamics. The other aspect is what are known as second order drift forces. I wouldn't go too much in detail about these because I don't think you are taught these currently in your sea-keeping motions course. But the idea is when you have multiple waves, you must have heard about Stokes wave. Is everybody here familiar with the name Stokes wave? Is everybody aware about the name or has at least heard the name?
No, sir.
Stokes wave, you have not heard? Professor,
could you repeat what you just said? Not very clear.
Sorry, Stokes wave. Stokes.
Oh, Stokes wave, yes. Okay.
Yeah,
Yes,
yeah, we have learned about it, I think.
You have learned about it, right? So in that you have the first order wave and the second order wave and the third order wave and Stokes fifth order wave and so on and so forth, right? So in a similar manner, we are primarily looking at, so when you are considering waves, you can go up to higher and higher orders and that is easy to go with because the problem is pretty straightforward to solve. But when you include the motion of the vessel as well, you can't go to very higher orders and analyze what the motion looks like. So currently, the second order motion itself is quite a challenging task, and that requires us to compute what are known as the second order drift forces. So this means that when I have a wave of 10 seconds and I have a wave of 11 seconds, then the envelope of those combined interfered waves will be at a very low frequency. And that low frequency can cause my offshore structure to keep on drifting around because the mooring lines do not provide a large stiffness in the surge, sway, and yaw directions. So that's particularly important for the offshore structures. And that implementation is definitely one module which we would like to see included in SIMDYN so that the offshore structure simulation can be made more robust. As I said, speed up of wave elevation calculation is one other thing which we are interested in. Particularly for the visualization, what is happening is we have to capture the wave elevation over a large grid. And we have to find improved methods to improve the computation speed. And that is something which will be of quite an interest to me personally to speed up the wave elevation calculation. That was on the numerical aspect of it. Also on the web application side, we are definitely looking for more help. And that comes in terms of this server is hosted on Amazon AWS. So you see, you look at, let me share my tab and see. Is this visible?
Yes, sir.
Yes.
Okay, so you see the running instances one, that's where the server is actually running. And that's where the IP address is. And that's the IP address at which I gave you the link where the website is hosted. Okay, so the idea is that we do require some help in setting up how to scale these applications up. So for that, you need to know a little bit more about AWS and other things, which I don't expect you people to know. But what I'm trying to say is I'm definitely trying to see if we can get more students from other departments into this side of it for helping us with the web application side. But something on the web application side which can be helped by the group of naval architects is on how to store the files and so that the user can have access to the files which they are generating. So for example, when you give the input files and it generates some output files, what is the structure in which we want to store them so that it can be retrieved later? Also, how can we come up with a subscription model for people outside the IIT system to use this facility? So currently it is set out as free, but as the program becomes more and more strong and more capability gets added to it, it makes sense that at some point we want to move into that. And in that case, how to go with the subscription model will become particularly important. So AWS side of the things, uh, how to store the files and subscription model. These are things, if you're interested in web development, if anybody is really curious in web server development or Python web applications, that would be an area where we would definitely be interested in having. Before I come back to this, let me go back to that simulation tab which we started, and let us see simulation has finished. Yes, it has. So let me share this tab. So if we now refresh, it should be able to load the results, and you'll see that the search, way, and yaw are 0 because I suppressed those modes in the input file, and only the heave, roll, and pitch results are out. Okay, the velocities and the displacement, all of them are provided. Now let's try to visualize this, and let us see before I do that, let me load the simulation file and save it. Okay, and now let me run the visualizer. So this is a real cool aspect of the visualization which I enjoy. It takes a little bit while to load up the files. So things like that are things which we definitely need help on. Okay, so let us see. All right. Are you able to see my visualization?
Yes, sir.
So you see that as the waves go by, you see that the ship is responding, and it's an oblique feed. So it experiences heave, pitch, and roll combined. And I've suppressed the other 3 modes so that the ship doesn't drift off, because I'm not moved it anyway. Right? So that's the idea of the visualization. And you see, one of the main challenges in this area is that you see each of these little triangles on the wave surface. We are computing a wave elevation at each of those triangles. And so therefore you see there is a lot of computation involved in computing the wave elevation at all these points. So how can we fasten that up is one big issue which one has to deal with, and I think that's an interesting problem from the point of view of how to fasten things up. So that's the thing. So let me come back to this. Oh no, I stopped sharing, didn't I? That's not what I intended. Okay. All right. So again, as I discussed in the previous presentation also, those of you who are interested, I will send out a Google form link by email, and you can fill it out and we can then get in touch. And the meeting again, whatever we are recording will be uploaded to YouTube so that it can be taken a look at later on. And similarly, people who have missed the meeting might also be able to take a look at it. And that link also will be sent out the email. Again, let me switch back to this visualization. And you can see that in real time, the heave, pitch, and roll plots on the bottom, they give you how much heave and how much instantaneously how it is varying. So all that it also has been built into the program. So this is what is in the rudimentary sense right now it is there. And we are definitely, it's a work in progress. It's not something which has been finished. And we are definitely looking for people to come up and contribute more to it so that it becomes a tool with IIT Madras, which we can then provide to professionals outside as well. And as students, whoever you are contributing, your contributions will be acknowledged on the website wherever you are. So just like as they have been acknowledged for these 3 students who started this work, more contributions will also be acknowledged. And this is a public IP, which means that it is not just within IIT. It is hosted on AWS, so anywhere in the world you should be able to see this website. Okay. And if at any point later on you want to go back and show somebody, hey, there is this tool which I built, you can always show it around, and it is accessible from any other place as well. Okay. Now, with that, I think I will leave it open to questions and comments and suggestions.
So what is the timeline of the conversation? Like what exact? What is the time duration that you're expecting?
The time duration, yes. So it depends, Satkirti, actually the time duration does depend on the type of the problem statement which we are choosing. So for example, the mooring line problem statement is fairly straightforward. It is not that complicated and can be implemented in a 6 to 7 months time easily, okay, or a little bit more. Less than a year, it can easily be implemented. But if it comes to maneuvering in waves, it might take a little over a year to do it, where you might be required to play around with more things. But then the question then becomes, if you have multiple people working on smaller bits of the same problem, it might not take as much time. So actually the answer to your question is relative and really depends on how many people are interested in one problem and how many people are coming together to solve it. If that is making sense.
Yeah, makes sense.
All right. More questions?
Hello, sir.
Yes.
How will be the selection process for the project?
A selection, I currently do not have a large selection process for the project unless until I am bombarded with too many names. Only then I will be really looking for the selection process. But from what I look here, it's a small group. I am not really keen on a selection process as yet. But yes, one thing is clear that here there is a prerequisite that you should be comfortable in programming in Python, because the entire application is built in Python. So if you want to contribute further on to it, you should be comfortable to program in Python.
Okay, sir.
All right. Any more questions? All right. I already see 2 of our contributors are already here. So Ashwin and Arundhati, if you want to add something to what I said, if I missed anything, please feel free to join in. I thought I saw Manoranjan as well. I don't see him now. Okay. All right. If there are no more questions, we will call it a day there. And I'll send out the email and the YouTube links for you to watch again in case if you're interested. And you can take a look at it and decide for yourself. Okay. Thank you for joining us. Let me stop recording now.